Hello students and welcome back to this module. Now here we are going to see direction angles of a line. So let us start our learning. Before we see direction angles in 3D, let us consider a line in XY plane. So XY plane means X axis and Y axis. So let us say there is a line which passes through origin. Now to draw the line, students, we ask what is angle made by the line with positive X axis. That is, we call it a theta. Now theta here is called as inclination. Right students? Now if we want to locate a line in a two-dimensional system, that is, to draw a line, only inclination gives idea of its direction. Right? This happens in two-dimensional geometry, that is on a single page. Now students, if I want to locate a line in three-dimensional space, that is with the help of X, Y and Z axis, let us see how the line can be located. So here is X, Y, Z and three-dimensional space. Now if we draw a line here which passes through origin again, now let us say L is the line. So here in space, to understand direction of a line, we calculate angle made by that line with positive x-axis. Let us assume this as alpha. So in the diagram there is alpha. Also we calculate angle with positive y-axis. Let us assume it as beta. So here comes beta, and we calculate angle with positive z-axis. Let us assume it as gamma. Okay, so students, if we know alpha, beta and gamma, then we can draw the line in three-dimensional space, right? So these angles alpha, beta, gamma are called as direction angles of a line. So here is the definition: direction angles. The angles made by a line with positive directions of x, y and z axis are called as direction angles. Now how do we denote them? They are denoted by alpha, beta, gamma. Right students, now let us proceed further with these direction angles. Now in this XYZ axis system, we know there are very much known lines, that is x-axis is a line in space, right? So let us think of x-axis. For x-axis, what could be direction angles? That is, what angles x-axis makes with positive x, positive y, positive z. Right? Let us think. For x-axis, it makes 0 degrees with itself, 90 degrees with y and z axis. That is, here is 90 degrees. So x-axis makes 90 with y, 90 with z. And hence we can say for x-axis, alpha is 0, beta is 90, gamma is 90. Right? Now similarly students, we can get direction angles of y and z axis. So if we see in the diagram, we can say for y axis alpha is 90, beta is 0 and gamma is 90. Similarly for z axis alpha is 90, beta is 90 and gamma is 0 degrees. Right? Now let us summarize these results all together. So here we have a table which says line alpha, beta, gamma. So first is x-axis, alpha is 0, 90, 90. Yeah. For y-axis, alpha, beta, gamma are 90, 0, 90. And for z, they are 90 degrees, 90 degrees, 0 degrees. Right students? So here we calculated direction angles for standard lines, that is XY, Z axis. Now, if we consider a line is parallel to x-axis, then can we calculate direction angles? Let us see. So here is a line which is parallel to x-axis. Now if we say students, x-axis makes 0, 90, 90 with all three axes. So this line, as it is parallel, we can see easily it makes alpha 0, beta 90 and gamma 90. That means parallel lines make same angles with coordinate axis, and hence we can say when the lines are parallel, their direction angles are same. Okay students, remember this statement for problem solving. Let us proceed. Now let's think of two vectors OA bar and OA dash bar. So here comes our coordinate system. There is a vector OA and there is a vector OA dash. Now let us think of direction angles for OA. Let's assume angle made by OA with x-axis as alpha. So here is alpha. So angle made by OA dash with positive x-axis will be pi minus alpha students. So for one vector OA, if alpha is the direction angle, then for opposite vector OA dash it is pi minus alpha. Similarly, we can say angles made by OA and OA dash with y-axis will be beta and pi minus beta, and angles made by OA and OA dash with positive z-axis will be gamma and pi minus gamma respectively. So here you can see in the diagram. Right? So if we summarize the result, students, with vectors OA and OA dash, we can say direction angles are alpha, beta, gamma and pi minus alpha, pi minus beta, pi minus gamma. Right? And hence, in general, if alpha, beta, gamma are direction angles of a line, then these values lie between 0 and 180, that is pi radians. Okay, students? So this is all about direction angles. Thank you.